This lesson is on distance and midpoint in the coordinate plane. So this is going to be a lot of algebra review. Hopefully your teachers had you do this little bit of radical simplifying so that it's familiar to you. And distance and midpoint formulas should be things that you saw. But even if you didn't, it's not that difficult, and I'm going to treat it as though you haven't seen it before. It's important that you watch a little bit of the video, pause it, write down what I've gone over, and then restart the video, because writing down information has been shown to help with comprehension and with memory. So please don't just screenshot it. You really need to write out the notes. I'm using my answer key because it's a lot neater than if I try to write it, and faster for you to listen to me and then write it yourself. Okay, so first of all, we're going to be doing something like breaking down the square root of 54 here. Okay, so if I wanted you to give me a decimal approximation for it, you would notice that since 54 lies between 49 and 64, that means that the square root of 54 as a decimal, the approximation for that decimal would lie in between 7 and 8. Now, you cannot give me an exact value because the square root of 54 is irrational. It means it goes on forever without repeating. That's why when we say we want you to give us an answer that's exact and simplified, then we want a simplified radical answer. So you're going to be giving answers such as 3 root 6, or 5 root 2, or 7 root 7. Okay, you're not going to give us decimals. Exact and simplified means an exact value, not a decimal approximation. So simplifying the radicals, 2 ways to do it. The way that you may remember having learned it in Algebra 1 is to do a factor tree. So we're breaking 57 down into 27 and 2. So we're factoring down to 27 and 2. 27 is 3 and 9. 9 is 3 and 3. So we have what's called the prime factorization, which means we're taking that 2, 3, 3, and 3 and splitting that up. So remember that if there is a pair of the same number, it can come outside as one of those numbers. Basically, this is the square root of 9, and the square root of 9 is 3. So when you take the square root of 3 times 3, it's a 3 on the outside. And then numbers that are left over are multiplied back together and kept underneath the radical sign. Now, a little bit more sophisticated way, and a lot of honor students prefer doing it this way, especially if you're familiar with having simplified it before. You might find this easier. Since 9 is a perfect square, it divides into 54 as 9 times 6, and so you can just take the square root of 9 and you get your 3 on the outside, and then your radical 6 carries along. So your exact and simplified answer for square root of 54 is 3 root 6. So let's talk about one more of those. So, for example, square root of 360, because 36 is a perfect square, and it's the biggest perfect square that divides into 360. Because the square root of 36 is 6, you can just factor 360 down as 36 times 10. The square root of 36 is 6. The 10 carries along on the inside. If when you're simplifying you have a multiple pairs of numbers on the inside of the radical, so let's say you have 2 2s and 2 3s, for example, that pair of 2s will come out as a single 2 on the outside, and that pair of 3s will come out as a single 3 on the outside, and they get multiplied together. So for example, you might end up with an answer on this one, 6 on the outside, and then the square root of something. Let's say you had maybe like an extra 2 and then a 5 left over that didn't have a partner. Those guys would get multiplied together and stay underneath the radical, and that would break down to be 6 root 10. The next concept is distance formula in the plane. This is not distance on a number line, this is distance in a 2D plane. So if you're given 2 ordered pairs, as you see in the picture here, x1, y1 is the first point, and x2, y2 is the coordinate pair for the second point, the distance formula is found in this way. So notice you're subtracting the x coordinates and squaring them. Then you're adding the difference of the y coordinates that's being squared, and in the end you're square rooting the answer. So it's the change in x squared plus the change in y squared, and then the square root of that entire quantity. So remember that the distance between 2 points is the same as the length of the segment. So if a problem asks you to find something like SR, That means, remember, the length of segment SR, which means you're doing the distance formula between the two endpoints S and R. So we're going to subtract the x-coordinates, 3 minus -2, that's going to be squared, and then we're subtracting the y's, -1 minus 14, and squaring that quantity. So order of operations, that becomes 5, that'll get squared, that's -15, which will become squared. Square the numbers gives you 25 and 225, or the square root of 250. Now, that's not simplified, so again, we're not going to grab a calculator and type in the square root of 250 because I don't want a decimal approximation. I want the exact and simplified value. So the square root of 250 you're breaking down as a radical. That happens to be a nice number since 25 is a perfect square, and it's the biggest perfect square, the only perfect square on this one that goes into it. We'll just be able to break that down as square root of 25 is 5, and then square root of 10 carries along. So your answer would be 5 root 10. The next concept is going to be the midpoint formula. So we've already talked about midpoints. The point halfway between the endpoints of the segment is a midpoint. It cuts a segment into two congruent halves. So it's the point that is directly halfway between the two endpoints. And the way you would find its location is to average the coordinates. So whatever the x-coordinates are, we're going to add the x-coordinates together and divide it by 2. That's averaging the x's. And then add the y's together and divide by 2. That's averaging the y's. So we're not finding a distance, we're finding the location, which is halfway between the two endpoints of the segment. So the coordinates, if you were looking for the midpoint of a segment EF, you would add the x-coordinates, which are 4 and 1, and then divide it by 2. Then you would add the y's, which are -4 and 7, and divide it by 2. And that gives you your x-coordinate, which will turn out to be 5 halves, and your y-coordinate, which turns out to be 3 halves. On this one, I don't care if you give me a fraction form or the decimal form because they're the same exact value. I never want you to round fractions unless the problem states that you should round it to the nearest tenth or whatever it says. But because 5 halves is exactly the same as 2.5, and 3 halves the same exact thing as 1.5, I don't mind the decimal answer for this one. The second kind of midpoint problem is where you're given something different than the last one. On the last one, you were given the two endpoints, and they were asking you to figure out where is the point that's halfway between that would make two congruent segments. This problem is different because on this one, they're saying you know the midpoint. Okay, you know the midpoint. One of the endpoints is given to be k at 4, 3. And you're looking for the other endpoint's coordinates. So we're trying to figure out where that endpoint is located. So we're still doing the midpoint formula, but the formula that we're doing the midpoints of would be the two endpoints. So we're saying if you average k's coordinates, 4, 3, and the xy, the unknown point's coordinates, you'll be able to figure out the midpoint values. So when we use the x-coordinate of the endpoint we know and the one we're looking for, that's 4 plus x and divided by 2, we should get the x value of the midpoint. When we average the y-coordinates, that's this equation right here. When we average the y-coordinates, 3 plus y divided by 2, that should equal the y-coordinate of the midpoint, which is this equation over here. Now, what I've done on the sides here in black is I multiplied both sides by 2 on the original equation to cancel this denominator. So that means it'll become 4 plus x equals 12 and x equals 8. That's the x-coordinate of your answer. So again, we're averaging the endpoints to equal the midpoint. That's how the midpoint formula works. But we have variables in there this time. I do not want you guessing and checking. You need to be able to show me algebra to get credit on these problems. Okay, so for the y1, again, we're doubling both sides to cancel the 2, and then it gives you a nice simple equation. You'll get -7 for your y-coordinate of the midpoint. So at this point, I would encourage you to pause the video and try problem number 4 yourself, and then you can come back and look at my work and see if it makes sense to you and you got it correct. The last problem in this lesson, we are finding whether two segments are congruent in a diagram. So they're asking you, in this picture, is segment AB congruent to segment BC? And that means we're going to use the distance formula to figure out whether they're the same value or not. So I'm using the coordinates here of point A for segment AB. The length of segment AB will use the -2, 4, and the 3, 1. Subtract the x coordinates, square that, subtract the y coordinates, square that, simplify it, and you'll get square root of 34. Okay, do the same thing for the other segment BC. I didn't show the work on that one, but if you did 0 minus 3 squared and -4 minus 1 squared, you'll end up getting the same value as you did on AB. So that's telling you that the segments are congruent to each other. So you would write it as segment AB is congruent to segment BC. Now, something you always want to pay attention to when you get an answer like the square root of 34, you want to make sure you check and see whether it breaks down. 34 factors is 17 and 2, and both of those are primes. So if you try to write it like this, neither of those numbers has a partner to come out, so it just stays the square root of 34. So to check for understanding, to practice here, I'd like you to try these two radicals, the square root of 120 and the square root of 450. You're giving me exact and simplified or simplest radical form answers, not decimal approximations. When you're showing work and needing to type answers, I kind of wanted to show you how to do that. So let's say you're breaking down the square root of 20. That's the square root of 4 times the square root of 5. So you would write it like this, square root of 4 times square root of 5 in parentheses. And then that reduces down to 2 square root of 5. So you'd write 2 and then square root of 5 in typed form. So that's the end of this lesson, and you'll be doing these two practice problems and giving your answer in simplest radical form, typing your answer in Edpuzzle as shown here.